That's all. Sharp. No, don't work, don't work. When it's vertical, it's horizontal. When it's horizontal, it's vertical.
So we have to now share. This will now be a different link from the other one.
Oh, you can see that first one.
That first one.
So
No, I've changed it to this one. I've done a new one. So Fabi, okay. Fabi, shall you come and do this one so that we'll save time with this.
Send all your contacts for them.
So this is now the correct link. Copy. So sorry, this is the correct link now.
check it.
What is that group? You cannot be passing like that too. It has started and follow me.
Okay, it has started. Please tell me what.
Is the mic on?
Is the mic on?
People that are joined are already complaining. Let me just start talking. Don't pass it again. Has anybody joined? And please. Okay, so today we're going to be treating geometrical progression. Welcome to class. So we're setting up, give us about 5 minutes to put everything in place so that the class will begin. So start sharing the link, invite others to join the class. We're starting very, very soon. So stay put, get your pen, your paper, and trust me, you're going to enjoy the class. I remain Earl Samm. You mute it once I stop talking. So can you hear me? Can you hear me clearly? If you can hear me clearly, type 1. If you can hear me clearly, type 1 before we start. Let's be sure everything is fine. If you can hear me clearly, type 1. Type 1. And can you see the board clearly? Can you see the board clearly? Let me see what they're typing. If you can hear me clearly, type 1 so I know that we're together. Okay. So hold on, let me get the device so that I can be monitoring what you are typing. Okay. So today our topic is geometrical progression. Now, if you remember, last week we treated arithmetic progression, AP. So let's do a quick recap on what we learned because the topics are related. So if you remember last week, we told you about series and sequences. We told you that series is a repeat pattern, right? If you look at this 1, 3, 5, 7, 9, there's a pattern we're following, right? And we told you that a series is the sum of a sequence. So for this sequence, a series of it will be 1 plus 3 plus 5 plus 7 plus 9 plus ... So we learned about series and sequence last week. Now we move to arithmetic progression, AP. So we told you that an AP is a kind of progression in which the difference between any two consecutive terms is constant. So, and that we called it common difference, right? So if you are following and you can hear me clearly, can you type 1 again? I want to be sure that we're together so that when we start our topic for the day, you will not miss a thing. Yes, so just type 1 again if you can hear me clearly. Okay, so I believe you can hear me clearly. So let's proceed. So we said an arithmetic progression is one in which the difference between any two consecutive terms is a constant. And then we gave things like, let's say 1, 4, 7, 10, and so on. Now, 4 minus 1 is 3. 7 minus 4 is 3. 10 minus 7 is 3. So the difference between the consecutive terms is constant. And we call that difference common difference. And we'll say that kind of progression is an arithmetic progression. So we went further to do a lot of calculations last week. The video is still on the channel. You can go back and watch. So today we're looking at a different type of progression called geometrical progression. Now, so our first question will be, what is a geometrical progression? So what is for short, we're going to be calling it GP. So what is a GP? Okay, for those of you writing, put it down this way. A geometrical progression, or GP, is one in which the ratio of any two consecutive terms is a constant. So remember, in arithmetic progression, we said the difference, right, between any two consecutive terms is a constant. Now, in this case, for geometrical progression, the ratio of any two consecutive terms is constant. Now that ratio is called common ratio. So remember, a geometrical progression is a progression in which the ratio of any two consecutive terms is constant. We call that ratio what? Common ratio. Let me give you an example. Look at this. 1, let me use a series, plus 2, plus 4, plus 8, plus, it goes on and on. Now, let's check, is this an arithmetic progression? Remember, in arithmetic progression, the difference between any two consecutive terms is constant, right? So 2 minus 1 is 2. 2 minus 1 is 1, right? 4 minus 2 is 2, not constant. 8 minus 4 is 4. So the difference is not constant. So obviously, this is not an arithmetic progression. Now let's see if it's a geometrical progression. Remember what I said, that the ratio, let's try. This is the first term, right? Second term, third term, fourth term, right? Let's go. T2 over T1, that's the ratio of the second term to the first term. So T2 over T1, that will be what? 2 over 1. The answer is what? 2, right? Two consecutive terms again, 4 and 2. Let's go. T3, the third term divided by the second term. So T3 over T2. What's the third term? 4, right? What's the second term? 2. And 4 over 2, the answer is 2. You see that it is the same. So once the ratio of any two consecutive terms in that progression is constant, what you have is a geometrical progression. So is it clear? So if the explanation is clear to you, type clear. Just type CLEAR, clear. Then I'll be sure that, yeah, you're following. Yes, is it clear? Or I re-explain that line? Check, 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 check. Is it clear? Okay, so it's clear to most of you. Now, I will give you 3 series or sequence. So you will tell me, number 1 is geometrical progression, number 2 is not geometrical. So you tell me whether it is geometrical or it is not geometrical. So I'm giving you 3 series or sequence, and I'm expecting your answers. So state whether, is camera picking this way I'm writing now? State whether the progression is geometrical. So number 1, we have 2 plus 4 plus 6 plus 8 plus 10 plus. Number 2, is it picking what I'm writing clearly? Okay. We have 1 plus 3 plus 9 plus 27 plus. Number 3, we have 1, 5. Okay, so we have 3 of them. So let me add a 4th one. So you tell me whether or not it is a geometrical progression based on what I've explained. Okay, so I increased it to 4. So state whether or not they are geometrical progression. So just say number 1, GP. Number 2, maybe not GP. Number 3, maybe GP. Number 4, maybe not GP. So just give me the answers in the comment section. I'm waiting. So I give you, just type your answers. Let me give you 60 seconds. Then I'll come back. We'll analyze together. All right, so welcome back. Most of you have put your answers there. So let's see what the real answer or the correct answers are. Okay. So for number one, we have, let's try T2 over T1, which is what? 4 over 2. The answer is 2, right? What about T3 over T2? Remember we said any two consecutive terms, the ratio is a constant. 6 divided by 4 is not 2. So 6 over 4 is not 2. That's 3 over 2. And it's not equal to 2. So number 1 is not GP. Okay, let me give you the straight answers. Number 2 is a GP. Number 3 is a GP. And number 4 is a GP. Okay, so if your answers are at variance with these ones, you can indicate so that, or that means I need to explain to you. So number 1 is not a GP because the ratio of the consecutive terms is not constant. Number 2 is a GP. Number 3 is a GP. And number 4 is a GP. So check anybody with a different answer. Let me read from my screen. Let's go on. So most of them got it from what we can see. So the next thing, so I'm rubbing this now. So if you are writing, write fast. So the next thing, since we know what a GP is now, we want to look at nth term of a GP. So the next thing is nth term of a GP. Now let's pick a typical GP and analyze a very simple one. So let's say 1 plus 2 plus 4 plus 8 plus that. So this is obviously a GP. So we know that, right? Now, what is the first term of this GP? The first term, T1. We are going to call it A. Remember, last week we called the first term A. So our T1 is equal to A. So our T1 is A, and the answer is what? The answer is 1 here. Our T2 will be A multiplied by R. A multiplied by R. That's that common ratio. You know, in a GP now, we have a ratio that is common, isn't it? Now, that common ratio, you're going to multiply the first term by that common ratio to get the second term. Now, what is the common ratio here? I want to see your answer. What's the common ratio, class? What's the common ratio? Type. I want to see your answer in the comment section. What is the common ratio of this progression? Ratio. Okay, so somebody got 2. Any other person getting 2? How many people have gotten 2? Okay, so the common ratio is obviously 2. Hope you can hear me. Mr. Excellence, can they hear me? Okay, so the common ratio is 2. So R in this case is 2. So now let's see that. So now our A is 1, right? Multiplied by our R, which is 2. And what's the answer? 2. and look at it, our second term is 2. Right? Now, third term, T3, will be A multiplied by R squared. That's you multiply by R and by another R to get to the third term. So the first term multiplied by one R, multiplied by another R to get this. So R times R is R squared, right? So let's see that in practice. So we'll have 1, which is the first term, so our A, multiplied by R, which is 2 squared, right? 2 squared is 4. 4 multiplied by 1 is 4. Guess what our third term is? 4. So that's how we form or we analyze geometrical progression to get the nth term. Now, let's be general. For the third term, we're using R squared. 3 minus 1 is 2. For the second term, R2, we're using R1 here. So at the end of the day, we'll have our general formula Tn equals to AR raised to power n minus 1. So take down this formula. So this is the formula for nth term of a geometrical progression. So for the nth term of a geometrical progression, Tn equals to AR raised to power n minus 1. Now let me give you what constitutes this formula. A is obviously so A is the first term, that's obvious. R is the common ratio, that's T2 over T1, which you get from T2 over T1, right? Or T3 over T2. Now, so AR, what about Tn itself? Tn is either the nth term or the last term. Since that's the term you are getting to, that's the last term based on the series you are treating. So Tn is the nth term or the last term. And then what is n itself? N is the number, that's this n you can see here. N is the number of terms. Okay, and that's it. So for nth term of a geometrical progression, our Tn equals to AR n minus 1. So where our A is the first term, our R is the common ratio, our Tn is the nth term or the the nth term or the last term. Our n is the number of terms. Now, based on what you have here, looking at your n and your n minus 1, for a GP, your 10th term, T10, will be equals to what? AR 10 minus 1, 9, right? Right? Our T21 will be what? AR what? AR what? 21 minus 1, 20. T103 will be what? AR what? What? 102. Just subtract 1 from it. All right, so based on this understanding, we're going to solve a few problems now before we move to the next subtopic. Now, if you have not subscribed to this channel, check. You'll see a subscribe button somewhere around your screen. So subscribe to the channel so that you can keep getting interesting solutions to mathematical problems. So subscribe now, I'm waiting. Subscribe now. Yeah, I see somebody doing it. Yeah, so subscribe, and let's proceed. So with all of this, I want to rub the board so that we can solve some problems. Then we'll move to these other problems here. So we'll leave the video on the channel. So even after the class has ended, you can take your time, rewind to any point and watch. So I need to rub this so that we can meet up with our targets. So let me put the formula somewhere. Tn equals to AR n minus 1, because we're going to be needing it a lot. So before we come to the questions here, let's solve this. Q1. It says find the sixth term of the GP. So I'm giving you the GP now. It is 4 plus 2 plus 1 plus 1 over 2 plus. Okay. This question says find the sixth term of the GP. This is the GP now. Right? It's a different question from this. Okay. So how do we do that? It says find the sixth term. Now don't forget, for our sixth term, T6, that's going to be what? AR raised to the power what? 6 minus 1, 5. This is clear, right? We've established this already. Now the thing is, what is our A? Remember, A is the first term, right? So in this case now, our A is what? 4. So we need A and R to get our T6, isn't it? So we know our A, that's obvious for the first term. Now what is our R? Remember, R is what? T2 over T1. Because you have been told it's a GP, you don't have to think, just go straight. Okay, so what's our T2? Which is 2 divided by 4, right? 2 divided by, 2, T2 divided by 4, T1, right? And that's 2 over 4, which is 1 over 2 when you bring to the lowest term. Okay, so we have everything it takes to get our answer. So our T6 finally will be what? A, which is 4, multiplied by R, which is 1 over 2, or raised to the power 5. Right? So we'll have 4 multiplied by, remember our law of indices. So this is going to be 1 raised to the power 5 divided by 2 raised to the power 5. Right? Yeah, law of indices. So we'll have 4 multiplied by 1 raised to the power 5 is 1. 2 raised to the power 5 is 32, right? That's 2 multiplied by 2, that's 4. Multiplied by another 2, that's 8. Multiplied by 2, that's 16. Multiplied by 2, that's the fifth one, gives us 32. So we can cancel out easily. This is over 1, right? So 4 here, 1, 4 times 8, 32. So our answer is 1 over 8. And that's it. So it's simple and straightforward. So that's our first example. We have to look for the sixth term of this geometrical progression. So on T6 is AR5, just getting our A first term, getting our R, and then we'll have our T6. So I want to give you another one quickly. Before we come here. So let me see if you understand it very well. So question 2, find the 10th term of the GP, the 10th term let's say 1, 3, 9, 27. Okay, 10 is far. Let's say the sixth term of this progression. So the question says find the sixth term of this GP 1, 3, 9, 27 dot dot dot. All right, so I'm giving you how many minutes? Okay, 60 seconds. So in 60 seconds, I want to see your answer to this geometrical progression. Your time starts now. Okay, so some of you got 2, 4, 3, right? Okay, let's see what the answers actually are, or the answer actually is. So from here, our first term, A is 1, and our R is T2 over T1, which is 3 divided by 1. That's 3 divided by 1, which is T3, right? Then our T6 will be AR5, which is A1 multiplied by R, as 3 raised to the power 5. So you have 1 multiplied by 3 raised to the power 5. That's 3 times 3, 9. Times 3 again, 27. 81 and 2, 4, 3. So final answer 2, 4, 3. So correct. I think Benita and the other person got it. Okay, so a good one. So let's quickly round up this end stem of a GP by answering these questions we have here. So are they obvious? Okay, so the first question says, find the fifth term of this progression. Yes, the answer to that will be obvious. So it says, find the fifth term of that progression. Can I rub this one? Yes. This one is clear enough. So question 1 from here, the progression is 2, 6, 18, and it says you find the fifth term. So remember, T5 will be what? AR4, right? Based on what we have here. So T5 is going to be AR4. Now, what's our A? Our A is obviously 2, and our R, remember, R is what? T2 over T1. Can you hear me? Sorry. I think the mic is off from here. Okay, I should explain this. Okay, yeah, just call me. You said? Okay, so come early next time, but for your sake, I'm going to re-explain this as reference point so that you can follow through for the others. So can you hear me? Just type 1 if you can hear me clearly. Can you hear me? If you can hear me clearly, type 1. Let me be sure that the sound is okay. So you can hear me now, right? Good. So for the sake of those just joining in, let me use this as reference to explain so that you can follow through to the end of the class. Now, in a geometrical progression, to find the end stem, this is the formula. Tn equals to AR raised to the power n minus 1. Now, in this case, we have to look for the fifth term. That's T5, the fifth term. So T5 is going to be AR raised to the power n minus 1. That's 5 minus 1, 4. Right? So if you have to look for 10th term, T10 will be AR 10 minus 1, 9. So let's establish that. Now, what is A? We're looking for T5 and we need AR raised to the power 4. What is A? A is the first term. I really hope you were here last week where we did arithmetic progression. The concept is the same, just the formula. So our first term, A9 is the first term, and our first term is 2, right? Obviously. So A is equal to 2. Now, how do we get R? R is called common ratio, and you get it from the ratio of any 2 consecutive terms. So I will use 1 and 2. So T2 divided by T1. That will give us the common ratio. So T2 divided by T1. So that was going to be what? 6 divided by 2. That's 6 of T2 divided by the first term, T1, 2. So that will give us 3. So and that's all we need. We only need A and R to get our fifth term. So T5 is A, which is 2, multiplied by R, which is 3 raised to power 4. Okay, so 3 raised to power 4 is 81. So we have 2 multiplied by 81. Three raised to the power 4, that's 3 multiplied by 3, 9, multiplied by 27, multiplied by 3 again, that's 81. So 162 is our 5th term. I know some of you will get it already. Right? Anybody got it already? 162. Okay, so that's number 1. Number 1 taken care of. And number 2, it says the first term of a GP is 10 and the third term is 40. Find the common ratio and the 5th term. Interesting. It says that the first term of the GP is 10 and the third term is 10. So they didn't give us R. And now we have to find the R, the common ratio, and the 5th term. So who knows what we'll do about this? Yes, you know what we'll do about it? Let me rub this. Remember I said the video will be left on the channel and you can always watch it even when we're done with the live class. So you can go back and copy. So the question says, number 2 now. It says that the first term, A, remember A is our first term, right? Is 10. And the third term, that's T3, equals to 40. And that's all we're given. Now we're asked to look for the first term, look for the common ratio and the 5th term. So we can do something. Remember, T3 equals to what? AR3 minus 1, right? 2. So from this equation, T3, which is AR2, is equal to 40. Okay? Now, if you look at it very well, we were given A, right? From the question, we were given A. So A is 10. So we can bring that in. So 10 multiplied by R squared, the answer is 40. Okay, so what do you think we can do from here? We can divide both sides by 10, right? Since we're looking for R. So if we divide both sides by 10, 10 cancels 10, our R squared equal to 4, right? Right? And now, if R squared is 2 square, remember 4 is 2 square, right? So we can do, this is R squared equals to 2 square, right? So we can equate the bases since the powers are equal and our R equal to 2. So first step taken care of. Now since we have an R of 2, I think in fact that's the first thing we're looking for. It says find the common ratio. So this one is taken care of. Now, and the 5th term. So how do we find the 5th term? That will be easy now. So T5 will be what? AR raised to the power 4, right? So T5 is AR raised to the power 4. So what's our A? From the question, it is 10. And our R is now 2, which is obvious. So we have 2 raised to the power 4. Right? Yeah. So we'll have 10 multiplied by 2 raised to the power 4. That's 2 multiplied by 2. That's 4. Multiplied by 2 again. That's 8. Multiplied by 2. That's 16. And our answer is 160. Yeah. So it might appear confusing, but it's interesting once you understand the concept. So we have just solved number 2. So number 3 now. More interesting because first term was not given. Unlike number 2, they gave us first term, they didn't give us common ratio. For number 3, no first term, no common ratio. So the question says the third term of a GP is 16, the third term. And the fifth term is 64. Find the 10th term. Very interesting one. So, but before I start solving number 3, hope you understand what I did in number 2. So if you don't understand what I did in number 2, you can indicate. And please come early to class so that you won't drag us back. So remember, I will leave the video in the channel. You can always come back to watch. Since no indication of I don't understand, so I assume everybody understands. So we'll proceed to solve number 3. So the third one says, the third term of a GP is 16. So let's put it this way, question 3 now. The third term of a GP, the third term is T3, right? The answer is what? 16. And the fifth term, 64. So T5 is 64. And that's all we have. Now we're required to get the 10th term. Okay, so what do we do? Let's think. So T3, remember, T3 is what? AR raised to the power 2, right? We've established this about 1,000 times now. So T3 is AR2, and the answer is 16. Let's call that equation 1. And at T5 is AR4, right? Let's call, equal to 64. Let's call that equation 2. Okay, so do we have sufficient facts to solve this? The answer is yes. So we now have simultaneous equations where A in the first equation is the same thing as the A in the second equation because it's the same progression, right? It's the same GP. R in the first equation is the same R in the second equation. So understanding this with knowledge of simultaneous equations, we can proceed. Now remember what I always say, mathematics builds on previous knowledge. So you can't jump the basics and solve advanced mathematics. So previous knowledge is important. So if you have not learned simultaneous equations, there are a lot of videos I've put out there on simultaneous equations that will help you understand that concept better. But I'll explain this clear enough for you to understand. So let's go. We can do equation 2, this is the bigger one, divided by equation 1. Remember last week we did equation 2 minus equation 1, right? Now in geometrical progression, because we deal with ratios, so we'll say equation 2 divided by equation 1. So let's try that. So in equation 2, from this part, we have AR4, right? Divided by equation 1 for this part is what? AR2. Equal to, on this other part, equation 2 is 64 divided by equation 1, 16. So get the point. Equation 2 divided by equation 1. So from this left-hand side, equation 2 is AR4 divided by equation 1, which is AR2, equal to, on the right-hand side now, we have equation 2, 64 divided by equation 1, 16. So A can cancel A, obviously. Remember our law of indices. When you are dividing same number or the same base, you subtract the powers, that of the denominator, from that of the numerator. Or even if you want to do R, there are 4 R's up there, right? Down here you have R, 2 R's. If you cancel these two, you have 2 R's there, which is R squared, right? Or you simply do R4 minus 2, that's R raised to the power 4 minus 2, right? Indices equal to 4. If you divide 64 by 16, you get 4 because 16 times 4 is 64. So what we'll have here is R raised to the power 2 equals to 4, which is not far from what we just did. So let's do it again. So R squared equals to 2 squared, right? Since the powers are equal, the bases have to be equal. So if we equate the powers, our R equal to 2. Okay. Let me get to the end. I will re-explain. So if you don't understand, just be calm. I will explain. But please try to come to class early. We start by 5 p.m. and we can't be waiting for you. So please join the class early so that you get the full concept. So let me get to the end. I will re-explain. So those that are following can just go on while I explain to those that's joining in. Okay. So we have r equal to 2. Now, but we're not done, because for us to get our T10, which is what the question requires, to find the 10th term, watch, T10 is what? AR9, isn't it? So now we know R, we still don't know A. But if you come back here, we can substitute this R into equation 1 to get our A. So the language is substitute 2, that's this 2 we got, for R in equation 1. So go back to your equation 1 or 2, any one of your choice. I prefer 1 because 1 is easier or simpler to work with. So let's substitute 2 for R in equation 1. So we have AR squared equals 16, right? So A multiplied by R, which is 2 squared, equal to 16. And 2 squared is 4, right? So A multiplied by 4 equal to 16. We can divide both sides by 4, so we get our A. 4 cancels for our A now equals to what? 4, because 4 times 4 is 16. So 4 here, 1, 4 here, 4. So our A is 4. Now we have A and R. We can easily get our 10th term, right? So our T10, hope you can see the board clearly. Our T10 is what? AR9. So which is what? A is 4 multiplied by 2 raised to the power 9. Okay, so if you have a calculator with you, you can do 2 raised to the power 9, but I don't have one here, so I'll manipulate. So 4 is 2 raised to the power 2, right? Multiplied by 2 raised to the power 9, isn't it? Remember our first law of indices. When you multiply same number, you add the powers. So our answer is 2 raised to the power 9 plus 2, 11. And then you are still free to use your calculator if you like that. Okay, so I'm going to re-explain what I've just done, but I don't want those that are following to wait for me explaining to those that are just coming. So can you zoom in question 4? Can you zoom in question or zoom out question 4? It says if 5x, y, 40 are in geometrical progression, find x and y. So 5, x, y, and 40 are in geometrical progression. Find x and y. We did something similar last week in arithmetic progression. Okay, so while I wait for your answer, let me re-explain this number 3 for the sake of those that are just joining. Okay, so if you want me to re-explain number 3, can you type 1? If you type 1 in the comment section, I'm going to re-explain number 3. But if no, there's no 1, we'll just go on with number 4. So I'm waiting for your answer. So focus on the question. Don't worry. Don't worry about me. Focus on the question for now, number 4. So if you don't understand what I did in number 3, possibly because you're just joining in, you can indicate 1. So I know some people need that explanation. Let me do it quickly. Welcome back. Anybody has done this? If you can't do it, it's fine. That's why you're here. So we're going to do it together. So let me re-explain number 3 quickly. Now, the number 3 question says, the first term of a geometrical progression is 10. Right? Sorry, number 3. The third term of a geometrical progression is 16. And the fifth term is 64. Find the 10th term. Now, for you to find the 10th term, T10, following this formula, is AR raised to the power 10 minus 1, 9. So this is what you need. You need A and R to find the 10th term. But unfortunately, all you were given from the question, there's no A and there's no R. Since I'm re-explaining, I think I can rub this now. I'm going to be a bit fast. Just follow me. Now, so all we were given is that the third term, T3, the third term is 16, and the fifth term is 64, and we're looking for the 10th term. Okay. Now, how do you get third term? T3 is AR2, right? Based on this formula, T5 is AR4. Just remove 1 from the number you are given. So T3 is AR2, right? And they said the answer is 16. So we call that equation 1. And at T5, based on what we have here, T5 will be AR5 minus 1, 4, right? So AR4 equal to 64. Let's call that equation 2. So class, if this is clear, what I've done here is clear to you, and you indicated 1 before. Can you indicate now? That's clear. So how we got equations 1 and 2? Are they clear? If they're clear enough, just type clear. I want to be sure I'm meeting your need. Yes, let me check. Okay, clear. Yeah, so I can see that it's clear to us. Now, what we do in a case like this, you do equation 2 divided by equation 1. And now we are dividing because in geometrical progression, we'll deal with ratios, not with sum or difference. We deal with ratios. So that's why we are dividing. So we'll divide equation 2 by equation 1. So if you look at that, from this side, our equation 2, we're doing equation 2 divided by equation 1, right? So from this left-hand side, equation 2 is AR4, right? Divided by equation 1, which is AR2, equal to, now from the right-hand side, we have equation 2, which is 64, divided by equation 1, which is 16. This is clear, right? Now, obviously, A can cancel out A, right? So R4 divided by R2. Remember our law of indices, second law of indices, division law. So R will be, once the numbers are the same, you subtract the power. So 4 minus 2, right? Equals to 16 here 1, 16 here 4, equals to 4. So you have R squared, 4 minus 2, 2, equals to 2 squared. 4 is 2 squared, isn't it? And since the powers are the same, you can equate the bases. So this cancels this, and our R equals to 2. And the person that got 2 or minus 2, you are not wrong. You are not wrong. But we're trying to keep it simple. So our R is 2. Because you did square roots, and square roots gives you plus or minus. I understand. So our R is 2. Now that we've known R to be 2, we can bring this R back to this equation and use it to find A. So substitute 2 for R in equation 1. So we're coming back to equation 1. Now, anywhere we see R, we're going to put 2 because the R is the same in both cases. So let's bring equation 1 down. So we have AR squared equals to 16. So we have A multiplied by R, which is 2 now. R is 2 square equals to 16. So we have A times 4 equal to 16. So if we divide both sides by 4, right? So our A now will be equal to what? 4. 4 here 1, 4 here 4. So our A is 4 and our R is 2. And that's all we need. Yes, you might not have come across this type before, but now you have seen it. So if they give you a question where you don't have A and R, from the parameters you are given, you can draw your A and R, which is what we have just done now. So what they want is the 10th term. So T10 is equal to AR raised to power 9. So what's our A from what we have here? 4. Multiplied by what's our R? 2 raised to power 9. Okay, mathematically, 4 is 2 squared, right? Multiplied by 2 raised to power 9. 4 is 2 squared, we have 2 raised to power 9, isn't it? Now remember our first law of indices, addition law. When you multiply same number, you add the powers. So what we'll have is 2 raised to power 2 plus 9, which is 2 raised to power 11. And that's it. So I believe it's clearer now. For those of you that are just joining in, I believe it's clearer now. Yeah. So we're moving to number 4. So if you want to write quickly. But remember, I will leave the video on the channel so you can always watch it again. So let's look at number 4 now. It says if 5, x, y, 40 are in geometrical progression, find x and y. Now, what we're doing now is similar to what we've just done, presented in a different way. And now, before I continue, don't forget, my name is Samm. I'm your favorite mathematics teacher. My job here is to simplify mathematics for you so that you can use it confidently, either in your exam, in your test. Just simplify mathematics for you so you can use it confidently. Now, I want you to do one thing quickly. Subscribe to the channel now. And you can share this link. We hold this class every Friday, 5 p.m. to 6:30 or 7 as it goes. So you can share the link with your classmates, your friends, so that the house is full and then we have fun while learning mathematics together. Okay, so I believe you've subscribed now. So let's solve. Okay, so we'll have 5x, y, 40. Okay. Now, nothing more. They just told us this is a geometrical progression and we're to look for x and y. So, what do you think we'll do? Now, I have the idea. Watch. Our first term equals to 5, right? That's obvious from the question, isn't it? And our fourth term, T4, that's 1, 2, 3, 4, right? Our fourth term equals to 40, isn't it? Do you understand what I've just done? The first term is 5 and the fourth term is 40. If you understand how I got these values, can you indicate I understand? Let me be sure that we're on the same page. If you understand, just indicate that you understand. Yes? So let me read chat. Everybody understands apart from Temple, right? Is it Temple that's the name or Talented? But I know you. All right, I know you're just trying to catch cruise, but let's go. So A is 5 and T4 is 40. Now remember, what is T4? AR raised to power 3, right? And it's equal to 40, isn't it? So T4 is AR raised to power 3. We've established that more than enough times now. So now, from the AR raised to power 3, we have A already as 5. So 5R cubed equal to 40. So what can we do from here? We divide both sides by 5, right? So 5 cancels 5, R cubed equal to 8. 5 here, 1, 5 here, 8. So the same principle. R raised to power 3 equals to 8 is 2 raised to power 3, right? Now, because the powers are the same, the bases have to be the same, and our R equal to 2. Now, getting R as 2, look at X. What is X? X is what? The second term, right? And Y is the what? Third term. How do you get second term? Second term is equal to what? AR1. Third term is what? AR2. 3 minus 1, 2, right? So our A is what? 5 multiplied by R is 2, right? Our R is 2. So times 2. Here, 5 times R squared, that's 2 squared. Okay, so some persons like Benita, right? And who else got the answer? So some persons got the answer already. So our X is 10 and our Y is 2 squared, 4. 4 times 5, 20. Favor got it. Who else? Blessing got it. Is the blessing the same as Ginika? Okay, Ginika got it. Blessing got it. Okay, that's good. So I'm glad that a lot of you understand the topic so far. Now, number 5. I will let you do number 5 because number 5 is just like number 3. I took my time to explain and re-explain. So I will allow you do number 5. I will give you 60 seconds. So can you zoom this number 5? So let's read together, but you are solving alone. It says the fourth term of a GP is 16, while the seventh term is 128. Find the sum of the third term. So you're looking for T3 and the common ratio. So what you're looking for is T3 plus common ratio. Find the sum of the third term and the common ratio. So how do you get third term? You need A and R first. So you are given fourth term. So T4 is 16. T7 is 128. So I think that's enough explanation. So your 60 seconds starts now. So let's go. I'm waiting for your answers in the comment section. Yeah, welcome back. So most of you already got the answer or something close. So the question says the fourth term is 16 and the seventh term is 128. This is a past jam question. If you live in Nigeria, you know jam exam. So this is a past jam question. So if you got it, you just got one jam question correctly. Okay, so fourth term. Remember, T4 is AR3, right? Equals to 16, equation 1. T7 is AR6 equal to 128, equation 2. So without wasting time, remember it is equation 2 divided by equation 1, right? So from this end, we have AR6 divided by AR3 equals to 128 divided by 16. So A cancels A. So we have R raised to power 6 minus 3, right? Equals to 8, right? Right? So if we do the same thing we've been doing, our R cube will be 2 raised to power 3, right? So we can equate the bases since the powers are equal and our R equal to 2. Now, because we're looking for the third term, T3, we're going to need A and R. So now that we've known our R as 2, we can come here and say our A. We can substitute 2 for R in equation 1. So pick equation 1, which is this. Anyway, we'll see R equals 2. So A multiplied by 2 raised to power 3, that's R is 2 now, right? Raised to power 3 equal to 16. So A multiplied by 2 raised to power 3, 8 equal to 16, right? Divide both sides by 8. Our A equals to 2. So A is 2 and R is 2. Remember, they're not looking for A or just R. We're looking for the sum of the third term, T3 and R. So let's get our T3. So T3 is AR2, right? Yeah, established. So our A is what? 2 multiplied by R, which is 2 raised to power 2. So 2 squared is 4 multiplied by 2, that's 8. So our T3 plus R will be 8 plus 2. Our R is 2, right? And our answer is 10. Alright, so if you got 10, congrats, you are correct. Sorry, my mic is off. Check the sound. Can you hear me, class? Can you hear me clearly? Can you hear me? Okay. Okay, so can you hear me? Can you hear me? You can hear me? Okay, people can hear me now. Okay. Okay, so a very interesting one. We've learned the nth term of a GP. Now, what if they want the sum? Okay, let's do it this way. Remember, these are still there. You can always get back and of a GP. Now, imagine that you have this GP. 1 plus 2 plus 4 plus. And now, they can ask you to look for the 1, 2, 3, the fourth term. You know that 4 times 2 is 8, right? But now they can ask you to look for the sum of the first 10 terms. So how do you handle that? So let me give you the formula first, then we come back. So sum of n terms of a GP. We'll call it Sn. Let's give the formula first, then we'll come back to analyze. So the sum of n terms of a GP equal to the sum of n terms of a GP is A into 1 minus R raised to the power n all over 1 minus R, where n is the number of terms and our R, as usual, is the common ratio. Our A is the first term and our Sn is the sum of n terms. You look at the formula very well. All right, so can you hear me now? Can you hear me? If you can hear me now, type 1 in the comment section or in the chat. If you can hear me, type. Can I see the chat? Okay, most people can hear me now. So let's go on. Sorry for the break in transmission. So I was trying to explain that the sum of n terms of a GP is given by this formula. So, and I've told you what N, R, A, and Sn mean. So if you have to look for the sum of the n terms of an AP, this is the formula you use. So that we'll round up quick, I want to give you the last formula we are going to need also, so that we can go on. Now, some sums get to the end. So we call that kind of sum, we'll call it sum to infinity. So sum to infinity is giving us sum to infinity equals to A over 1 minus R. So now watch, let's get the picture clear. If the series or sequence, the series you are given is an infinite one, so you find the sum to infinity. If it's a finite one, you find the sum. So is that clear? So you might be given an infinite series or a finite one. If it's infinite, you use this sum to find the sum to infinity of the series. If it's a finite one, you use a formula to find the sum of the n terms of that series. Now in this other case, your A is the same as A first term, R is the same as common ratio, but now you have this sum to infinity, which is sum to infinity. Okay, so now with these two formulas, we can solve problems, enough problems till the end of the class. So that's the target. So let me give you a few questions now. So just watch out that if you're looking for sum of n terms use this. If you're looking for sum to infinity, use this. So I'll mix the questions. All right, look at this number 1 now. Are we looking for sum of n terms or sum to infinity? The question says find the sum of the first 6 terms. So you are looking for n terms. You are given the number, right? 6. So you are using this formula. Okay, so we have 2 questions. 2 questions. So the first one says, find the sum of the first 6 terms of the progression. Okay, so what do we do in this case? Okay, should I rub the formulas now? Please write them down because we need to solve here. And remember, the video will still be up after the live, so you can always go back and forth to any point you want and get the information. Okay, so this first question, we have 1 plus 2 plus 4 plus dot dot dot. And we're looking for the sum of the first 6 terms, right? Now, what's our A in this case? Our A is 1, obviously. What is our R? Remember, our R is T2 over T1, right? Which is 2 over 1, which is 2, isn't it? What's our N? The number of terms we are looking for is 6. Now, remember our formula. The formula says that what? Sn equals to A into 1 minus R raised to the power n